Next, we are going into FD, CANFD. What is CAN? Flexible data rate. We are going to discuss about that for some time. And then we are going to end this CAN basic session. CANFD is an extension to the original CAN bus protocol that was specified in ISO 11898-1. That is what ISO number for CAN standard. They extended the CAN basic CAN that we have, standard CAN that we have, to the next level. Developed in 2011 and released in 2012 by the Bosch. CANFD has 5 times more capacity than our standard CAN. You can transmit up to 64 bytes, nearly 4096 bit in a single frame. That is the advantage that we have. But a limitation with when we go like that, when we transmit 4096 bits, voltage pulses for a single frame, there is a problem of the transmission rate. That's why what they do, they use 2 type of baud rates. Whenever you have a FD product, you will configure 2 baud rates. One baud rate is for to transmit control signals, control and handshaking signal, and one baud rate which is higher baud rate for transmitting the data. To transmit the data with high speed, we use a higher baud rate. So that is a difference. Here is the diagram. You have a startup frame, arbitration field. All these things will go standard baud rate. The moment it comes to the data, they will automatically, but you no need to go and switch anything. Initially, you will configure 2 baud rate. That first baud rate, otherwise the standard baud rate will be used to transmit handshaking signal. The moment it transmit the data bits, automatically the CAN chip will switch the baud rate to the higher one. That is second baud rate. Till how long it will maintain that baud rate? Till it complete the data transmission. The moment the last bit of data bit is done, it will again revert back to normal baud rate. That means the standard baud rate. Only when they transmit the data bits in a frame, they will go in one baud rate. For the rest of the bits, they will transmit in a standard baud rate. That's why whenever you have CANFD product, CANFD ECU, you will configure 2 baud rates for that. But the second higher baud rate optional. If you want to maintain both of them in the same baud rate, you can do, not a problem. But it is good to have different baud rates because your data is very lengthy. It is good to use higher baud rate for data. They provide that option to switch the baud rate. In case of FD, we have some 3 additional bits. What are those? Extended data length, and then baud rate switch, and then error state indicator. Extended data length is a bit like RTR bit or IDE bit to differentiate your FD frame from the standard CAN frame that we used to have, like 11-bit CAN frame or 29-bit CAN frame that we have, standard frame. To differentiate that from the FD frame, we use this bit, that is extended data length bit. Then baud rates, this bit should be set to 1 in order for all FD frame. When you go and see the EDL bit will be 1 for all FD frame. Next, baud rate switch. This baud rate switch should be 1 when you want to have 2 different baud rates. When there is no need of baud rate switching, you can keep this bit as 0. That is baud rate switch. Next, error state indicator. In case of FD, you don't have separate frame called error FD frame. No, not like that. There is, in the same frame itself, they will have 1 bit that called error state indicator. This error state indicator bit will be 1 for passive error and 0 for active error, I believe. So that is the difference. There is no separate error frame in case of FD that we have to understand. That is completely covered by only one bit, error state indicator bit. The extended data length bit that is used to differentiate standard CAN frame from the FD frame. Baud rate it is to switch the optional baud rate when we are transmitting the data. The error state indicator is here. See here, ESI, the error state indicator flag is transmitted dominant by the error active nodes and recessive by the error passive nodes. So when they are having error active or passive, they will reflect their states not by the frame, error frame, but by the single bit in the frame. So that is what error state indicator that we have to know about FD frame. Then the DLC for DLC bit for FD frame as well as CAN standard frame is 4-bit only. But to represent 8, we need 4 bits. That's why we have 4 bits in a CAN. For DLC bit, they allotted 4 bits. But when in case of FD, you can transmit up to 64. If that is the case, to represent 64, at least we have 7 bits to represent 64 because 110, 01, 00. 4 bits for 4 and then 3 bits for 6. Totally 7 bits you need. But they don't go for 7 bits for DLC. Instead, they are handling it with 4 bits only. How? After 8, if you give 9, 1001 means they consider that as 12 bytes you are going to transmit. If it is 1010, A means 16 bits, B means 16 bytes, B means 20 bytes, C means 24 bytes, D means 32 bytes, E means 48 bytes. If you set all bits to 1, you can transmit 64 bytes. That's all about DLC, handling of FD. That's all. Your CAN basic is